Good afternoon, everybody, and welcome to today's chemistry lesson. Today we're going to be talking about finding the missing pieces in a reaction, something that we've seen before in the past, but we've always looked at either a double replacement or a single replacement, whereas here we will be focusing in on really the organic side of missing pieces. We're going to see lots of C's and H's, and just talk it through how this looks a little bit different for organic chem than it does for some of our other topics, right? Some of our inorganic things. Right. Finding the missing piece of reaction is just like solving a puzzle. We need to make sure that mass is conserved, just like always, which means the left side and the right side must match. They need the same number of C's, the same number of H's, the same number of O's, the same number of N's, right? All of those pieces must be the same on both sides. And so if we're going to figure out what a missing piece is, it's really just a counting game where we're going to account for each of the missing things, right? We're going to take a look at this reaction here and compare the left and the right side. Here I've got my mystery thing and 8 O2s. 8 O2s is going to give me a total of 16 O's. I have no C's. I have no H's. Here on the right side of the equation, I have 5 carbon dioxides. 5 carbon dioxides is going to give me 5 C's. It's going to give me 10 O's. It's going to give me no H's. 6 waters is going to give me 12 O's and an additional 6 O's. It's going to give me 12 H's and an additional 6 O's, which is going to bring our total number of O's to 16. If I'm looking for my missing piece, I'm comparing my left and my right. Here I've got 0 C's and 0 H's and 16 O's. Here I've got 5 C's, 12 H's, and 16 O's. My O's match. Hooray. Fantastic. Amazing. But my C's and my H's don't. So that means my missing thing needs to be C5H12. Right, so now, by checking left and right, I've got 5 and 12 and 16, which is going to match and match and match, making this reaction balanced and complete. With organic chem, there are a few little differences that we can see. Namely, one of those differences is about the actual product. Right? There's a difference. It doesn't matter here, but there's a difference between this thing and this thing. They're both C2H5O. C2H6O. Right, they're both of the same number of C's and H's and O's, but we know that an alcohol and an ether are two different things. Right here up top, ether, here on the bottom, alcohol. So this would correctly fit in a spot to tell me what I'm missing from an equation, but it doesn't tell me ether versus alcohol. So that's one of the things that we're going to see pop up in a second. Right. Here again, we have a reaction with a piece missing. We're going to still do our same check, right? We're still going to be looking at what we have on both sides and what we need to fill in the blank. It is just like balancing an equation. It's just a little bit different, right? We're focusing in a little bit on the differences between what we've already done and how organic makes this a little bit different. All right, here, just like we've done in balancing equations, we're going to check our H's, we're going to check our O's, we're going to check our C's. We've got 8 C's, we've got 20 H's, and we've got 26 O's. All right, by looking at 2 C4H10s and 13 O2s. Here from 8 CO2s, we're going to get 8 C's. We're going to get 16 O's. And we've got no H's. If I want to look at my missing pieces, right, those things that I don't have here, I am missing 20 H's. And I'm missing 10 O's. Now I've got 2 choices here that will accurately represent what I'm missing, right? I can say 10 H2O's, that's 20 H's and 10 O's. But I could also say H20O10, that's 20 H's and 10 O's. And this is one of the spots where organic chemistry is a little bit different, right? I know that this doesn't exist, right? I can't connect a reasonable H and O like this, right? I can't connect all of my pieces together to get 20 H's and 10 O's together. But I do know that water is a thing that exists, and I know that 10 of them will give me these pieces. How do I tell the difference? And that's where the organic reactions from yesterday come in, right? The organic reactions are going to tell me, hey, this is a combustion. Right? We've got a hydrocarbon with oxygen making CO2, and a mystery thing that if we recognize our pattern, we know that this mystery thing should be water, right? Hydrocarbon plus oxygen makes CO2 and water, which is going to narrow down our answer, right? Definitely not 2 because it's not the right number. Definitely not 3 because I can't make this thing. But here, for choice 1, it's water, which is the thing I know belongs in that final spot, and it has the right amount of H's and O's if I have 10 of them. Right, leading me to my correct answer of choice 1. Right, so knowing the different organic reactions helps us when we're over here looking at balancing and finding these missing pieces. One more example here, taken off of an old Regents exam, is going to be this reaction here. Right. Here we again have a missing piece. Here instead of a line underneath, right, a missing blank, they gave us an X, and they say which compound is represented by X. They give us condensed structural formulas for 2 big compounds and water, and ask us, well, which of the following things fits in this blank? Right? And so it's not about having the different reactions memorized. Right? It's not about committing those to memory. You can answer this question correctly without having those things memorized, but it does give you a little bit of a boost. It lets you save a little bit of time if you can recognize this reaction as an esterification. Right, and we'll talk about that in a second. All right, but first we're going to do what we would do normally, and that is count our C's and H's on both sides, check what we've got, and check what we're missing. All right, I've got over here 1, 2, 3, 4 C's. I've got 3. Let me erase those marks there. I've got 3, 4, 5, 6, 7, 8 H's. And I've got 2 O's. Not 20, 2, and then a gap, O's. And then I've got my mystery compound on the other side. All right, this is going to be one of these choices. On the right side, I've got 1, 2, 3, 4, 5, 6 H's, or sorry, 6 C's. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 H's. And then I've got 1, 2, 3 O's. Right? Is OH2 the same as H2O? Yes. This is the same as this. You'll never see it written this way because, like we talked about in the past, positive comes first. And because H is the positive thing, it will always come before the O. But these are, if you're writing, these are the same thing. All right, so if I want to look at what's missing, I'm missing 2 C's. I'm missing 6 H's. And I'm missing 1 O. So of my choices here, I'm looking for 2 C's, 6 H's, 1 O. Right here, 1, 2, 3 C's. Wah, not right. Here, 1, 2, 3 C's. Wah, not right. Here, 1, 2 C's. Oh, off to a good start. 3, 4 H's. Wah, not right. But here, 2 C's, 3, 4, 5, 6 H's, and 1 O. That has all of our missing pieces, and that'll make this the correct answer. Right. Again, notice I didn't need the fact that this is an esterification to answer this question. But let's rewind it back for a second. I look here at this reaction. And I draw out my pieces and I say, okay, I've got an organic acid here. I draw this out and I say, ooh, that is an ester. And I made water. I know from class that in this kind of a reaction, it's an organic acid plus an alcohol that makes an ester and water. So I know that my answer has to be an alcohol. So I'm looking, this, not an alcohol, right? Alcohols have OHs at the end. This, not an alcohol. Ooh, here's an alcohol. Maybe, that's got an OH at the end. Here's an alcohol. When I draw these two things out, that is an alcohol, but this, when I actually draw it, is an aldehyde. It's not an alcohol. So without even counting my atoms here, there's only one alcohol of these choices. I need an alcohol to fit in that blank, so it's still choice 1 as the correct answer. Right? Again, not like you need to memorize those reactions, but if you know them, it gives you an alternate approach to solving problems like this. Right, so you can take either approach. You can say to yourself, okay, I'm going to count my C's, count my H's, count my O's, compare left to right, and find what's missing. You could also say, hey, I recognize this reaction type, I recognize these functional groups, and I can identify, hey, that's an organic acid, hey, that's an ester. This whole reaction needs an alcohol in order to be a proper esterification. Which one of my choices is an alcohol? Right. Either way is correct. Either way will lead you to the right answer. Right. In this case, in this specific example, you don't actually need to know that this is an esterification to answer it. Right. But the correct answer at the end of the day, either way you do it, is choice 1. And that's actually all for today, everybody. I hope you have a fantastic day. If you have any questions, comments, or concerns, please pop into tutoring and office hours using the Google Meet on our Google Classroom. And I'll see you all later. Have a great day.